Hello, everyone. I'm glad to be here today. As Dave was saying, I'm from Microsoft. I work on the Azure Cache for Redis, which means we're the cloud Redis offering from Microsoft in Azure. Dave was accusing me of wearing a disguise today because I have a hat and glasses and don't look much like that. So sorry. It really is me. I have worked at Microsoft for about 17 years. I started there as a software, well, I started out as a testing engineer, testing the .NET framework, making sure that it worked as we expected it to work. Switched over to being a developer on a server product, and then I got switched back to working on the .NET framework as a developer. And then through various reorgs and stuff like that, I ended up becoming a manager over a couple of teams, different products within Microsoft, and then eventually was asked to help build the Redis service within Azure. So I do want to call out that I am not an ASP.NET Core developer. And the reason I'm calling that out is I want to show you that you don't have to be an expert to use these tools. As for agenda, we're going to talk a little bit about ASP.NET Core. We're going to use VS Code, which is Microsoft's open source lightweight code editor. We'll talk a little bit about that. And then we're going to just kind of show how to enable Redis functionality inside of an ASP.NET Core web app. And then we'll do some session state stuff as well. For those that don't know much about ASP.NET Core, so ASP.NET is the long-standing web application framework from Microsoft built on the .NET framework. The core got added because after a while, the full framework ships with Windows, but we obviously recognize the need to have a cross-platform solution. And so the .NET Framework Core and ASP.NET Core were built. They are completely open source. They are free, and they're cross-platform. So you can now run your .NET applications on Windows, on Mac, on Linux. You build it in one place. You don't have to recompile when you drop to another platform. If you want to know more, there's a little bit of a web page there. VS Code, like I said, is the editor I'm going to use. Visual Studio is our flagship software editing software development and editing and debugging tool, and it's a paid product. VS Code is the free version of that and has quickly gained a lot of popularity. It's free. It runs on, again, cross-platform, Mac, Windows, Linux, and it's built to develop in many different languages, not just the .NET framework. It is also open source, and it by default it comes with support for JavaScript, TypeScript, and Node. And then it has this very rich ecosystem of extensions to the VS Code platform, so that you can easily add support for C# or Ruby or what other languages you want, Python, etc. Again, I've got a URL where you can learn a little bit more if you want to learn about VS Code. Today, I will also, one of the things I didn't include in the slide, I'm running on Windows right here on my laptop, but I'm going to be hosting Redis inside of a Linux kernel running on my Windows machine. There's this fairly new thing that Windows has, the Windows subsystem for Linux, which in my case is a full-blown Ubuntu kernel running on Windows. And so we will host Redis in Ubuntu on my machine. The app that I'm going to show today is a web app. It's called Flight Finder. It's a sample that's taken from the web for ASP.NET Core. I did not write it. I did not try to write it. I just wanted to modify something that would kind of demonstrate the concepts of what I'm trying to get across today, without a lot of extra fluff. So with that quick intro, let's jump into some demo logic. Let's see, there we go. So again, VS Code, I've got this actually running. I need to stop it. VS Code. I've got me a quick little cheat sheet that I might refer to here and there just to kind of remind me what to talk about. This app is built up of, it's a .NET Framework, ASP.NET Core web app running MVC. It's running a simple REST API on the server side, and then the browser is calling into the REST API to get flight information. So let me hurry and run this. It's all running locally. Let me just quickly show you this while we're waiting. Here I've got Redis running locally, again on that Linux subsystem. Is that big enough that you can kind of see it? Yeah, it looks like it's okay. And then I will refer to Redis CLI. Let me just recreate that connection just to make sure it's still good. Now, since this is a fairly new build, I'm on kind of a slower network. It's grabbing some packages off of the internet for build, and then here we go. You can see the simple app. We've got, you choose an airport from, to, time, the type of flight that you want to take, and you can hit search. And you'll notice the box down here goes gray. That's it running the query. This is all data that's just randomized fake data. This is not, I'm not calling into any real service in the back. So you can see that it changes every time I run that. Obviously, if we were calling into a real service, that would be quite expensive, and so we want to add some caching. Let me stop that. Now, ASP.NET Core has kind of some common constructs for getting your apps up and running. One of them is that you can register an entry point for registering your dependency injection services, for deciding which features within ASP.NET you want to enable. And so that's what I'm looking at here. Is this big enough? It looks, raise your hand if that's, or thumbs down if it's not big enough in the back. Looks like it's okay. So here's the entry point for where we get a chance to inject services into the system. This service will be called, this method will be called automatically by the SIT framework on startup. And so we want to just tell it about StackExchange.Redis, the caching implementation that's used under the covers in this particular implementation. I'm using an open source. Actually, we're using a package shipped by ASP.NET Core team that uses StackExchange.Redis, which is an open source client for Redis, probably one of the more popular clients for the .NET framework. Now what I've done here is I've just uncommented the code, and that's going to add this iDistributed cache interface, an instance of that, into the dependency injection system. The configuration is pretty straightforward. I'm just telling it to connect to localhost. If I wanted to connect this to the cloud, then I would just, instead of saying localhost, I would give the connection string for talking to the Redis instance in the cloud. The instance name is really just an app identifier. If you decide you want to use the same Redis instance under the covers for multiple applications, this is just a piece of a string that gets kind of concatenated on the front of your keys so that you have some level of data isolation inside of the cache. Okay, that seems good. Now that puts it into the dependency injection system, but it doesn't actually make it so we're using it. So we're going to jump over here to, well, let me jump here real quick. One thing that I did have to do by default was I had to add this reference to a package that gets pulled in at build time. So let's look at the server-side code just a little bit. Here's our search method that gets invoked inside of our REST API on the server. You can see right now it's just calling into a data source and finding the various flights with the criteria that we've specified. A couple of .NET concepts that I want to quickly point out. Async task is really just it's a way of identifying an asynchronous method that looks, that you write as if it were synchronous, but then under the covers, it knows when you're going asynchronous and will release the thread for use by other parts of the system. And then when that asynchronous task completes, it will resume the code at the exact same place where it left off. So I write my code as if it's synchronous, throw in a couple keywords, and I get very highly asynchronous, very well-behaved thread usage within my application. Just makes writing asynchronous code much easier. So you'll see that throughout the project today. A variant of that is async void that I might have in a couple places. If it says async void, that just means fire and forget. You know, where I'm kicking off an asynchronous task and then don't come back to this same thread. Okay. So in order to get that iDistributed cache interface, I need to simply add a constructor to my object that has that type as a parameter to the constructor. And then ASP.NET Core will automatically look at the constructors on the object that's being used, and it will see that it wants a distributed cache. It'll go to the dependency injection system, and it'll grab that object out of the DI. We hold on to it into a field, and then now we're going to just quickly replace this search implementation with a different one that knows, oops, wrong direction, sorry. That knows about the cache. This line of code that I'm highlighting is effectively the code that was there before. And so we've added this other stuff before it and after it. Pretty simple. The criteria has a method that helps me get a key for this particular criteria. It's really just a string that looks something like what you see up here in the comment to kind of help identify this particular piece of data and distinguish it, and so that we can find it again if we look in the cache. Now, the iDistributed cache API, another quick concept I want to explain. The iDistributed cache interface is fairly simplistic. It doesn't have a lot of APIs on it. It has a get, has a set, a refresh, and it really works in byte arrays and a few options to control how the cache behaves. But I don't want my code to have knowledge of all of these moving parts that are involved in doing something more with cache than having to deal with byte arrays. So what I did is I created what's called a set of extension methods. The .NET Framework has a concept where you can create your own class, and then you can extend methods, or basically attach methods to another object type, and it looks like they're methods that come with that object, but really I've created them for my use. So a simple example is I added, let's look at set. I added a generic method that takes, where I can tell it what type I'm serializing. I can pass that value in, and then I can call into some JSON serialization code to serialize it into a string, and then I can call into another extension method on the iDistributed cache that takes a string instead of a byte array. So that simplifies my app. I have one place in code that deals with serializing, and then I have a getter that does something very similar. You can kind of see what's going on there. But then I added some additional helpers that are specific to the data type that I'm using in this particular code path. So we've added that. Let's go back over to our search controller. Again, we do a search ID. We check the cache to see if it exists there. If it is null, we didn't find it in the cache, we're going to go ahead and get the real data, and then we're going to add it to the cache before we return it back to the caller. So let's give that a try and see if that works. I think this is the old session, so we're going to let the new one kick in. Okay, so again, the new page comes up. We're running the same search we did before. First time I hit it, It's taking a little while because it's calling into it's spinning up some of the services in the background on that first request. But you can see that before, when we didn't have caching, the data was changing every time I hit search because of that randomized data. But you can see that here, it's coming from the cache. Now, I had configured the data when I put it into the cache to have a sliding expiration of 10 seconds and an absolute expiration of, I think, 20 seconds. And so what that means is as long as I'm hitting the cache, like if I hit it every second, then it's going to stay beyond that original 10 seconds. And then it will last in the cache a maximum of 20 seconds. So if I hit it again, it should so we got different data this time, and you can see. Now we also can change the type of flight. So we get different data. This one's caching. So it's working like we expect. Okay? Goes back to the original data. There we go. Let's quickly look at what this does in Redis, just for kicks and giggles. Let's run that again and get fresh data. Okay. So there's the data. You can see that there's a key in there. If we were to grab that, let's see. I had to change my hget_all. That's not going to be there because it expired after that 20 seconds. Run it again. Same search. There's our serialized list of flights that we had found. So just to give you a quick feel for what it looks like. Okay, so that's caching in a nutshell. Super easy. Just add a couple calls in to initialize the system with the right objects, and you're good to go. Now, one of the other things that web page had was on the right-hand side, it had what it called a short list. The short list was an in-memory, in the browser list of flights that I kind of flagged as oh, this looks interesting. So I could have hit the add button next to any one of those flights, and it would have popped it off to that right-hand side. But, you know, since it's in the browser, it means it could get lost pretty easily. So we're going to use session we're going to use that piece of data just as a way to kind of demonstrate how sessions work within ASP.NET Core. Again, we're going to go back to our startup. Now, we talked a little about configure services, and that's where you add things into dependency injection, which we have to do. So we're going to just uncomment this code here. Okay, and that's going to add something called an iSession object, and that gives you the ability to connect to a session and put data into the session, which is in the background. This add session is just using this same configuration for this. It's using the iDistributed cache under the covers to store the session. Again, we have some timeout options. In this case, I'm telling it I want to use cookies. So it's going to use a cookie to help store the session ID so that when they call back into the server knows where to find the data in the cache. Okay? The second thing that we didn't yet talk about is a configure method. Now, this is where you take ASP.NET and you say which systems, which of the intrinsic systems in ASP.NET do I want to add to the system? Do I want to enable? In this case, we want to turn on session. So we're just telling the system, yes, we're using session, and that'll hook up the piece to where it automatically sends the cookie back to the client, it automatically grabs that, and it'll populate some things on the server side when we go to run some code. Okay? The other thing I'm doing is I'm adding another API controller. In the flight search controller, you'll notice I wasn't inheriting from anything. It's just a standard class. For the shortlist controller, I am inheriting from a controller class. And what that gives me is it gives me access to a field within the object that is the HTTP context for the current call so that I can get access to the service or to the session. You notice we got some errors on here, and that's because, again, I've kind of extended the iSession interface to have some extra helpers for grabbing things out of the session object, the session data store. Okay, so hopefully this works. This is a piece I added to the system just a day and a half ago and didn't get as much time to spend on it. So we're crossing our fingers that everything works. It's building, ready to start the, oh, I didn't run it, I just built it. Okay, so now we're going to just quickly run the search. You can see it takes a little while because the flight data isn't there. If I click add, it starts popping up over here. If we go to our CLI, we can go keys, asterisk. You can see the search is in there, but my session is not. So what did I do wrong? Okay, I've done something wrong. Well, we're kind of out of time, but basically that's the crux of how it works. We're adding to the session. We have a call. Let's see. Let me just show you real quick right here. So here we do HTTP context.session.get shortlist. If I would have had, I must have missed something when I did that last piece this morning. So anyway, that's kind of the crux of it. Normally that would show up. It was working earlier. I don't know what I did differently today. So let's go back real quick here. In summary, using Redis and ASP.NET Core is pretty simple. You just light up a couple things with a few lines of code. You can easily extend the interface to make the caching layer look customizable to your application, the methods you want on your system, and then you can learn some more. You can get the demo that I used today from there. VS Code, again, free, lightweight, works on cross-platform. It's a great tool, very easy to use, and it works with many languages. That's all I have for today. If you have any questions, I'm willing to take a couple of minutes of questions. We don't have a whole lot of time, but.
Okay, anybody got any questions? All right. Oh, there's one right there. Here you go. Hold on 1 second.
Will you put the modified version of the sample online? The one that to which you added
the stuff that I added?
Yeah.
Yeah, I can do that.
That'd be great. Thanks.
I will. So my GitHub profile is github.com/John Cole, JONCOLE. I'll find some place to put it there if you want to see it.
Thanks.
Okay. Any other questions? Okay. Thank you very much, John.